Hi everybody, it's me again. So now we get to the first example for the quiz 3 review. It is section 3.2, classroom example 3. So we have this problem here. A rope is being wound around a drum with radius 0.327 meters. How much rope will be wound around the drum if the drum is rotated through an angle of 132 degrees, 132.6 degrees. So what we want to do, start checking off from your arc length formula. Okay, let me actually just erase this and reiterate. That our formula is S equals R theta. How did we know that we needed to use the length? Like if we weren't given this part saying find the length, how would we know? Well, how much rope will be wound around the drum? That's our hint. We're actually starting right here. Okay, and the amount of rope given around, the amount of rope wound around the drum is actually given by S. Okay, so when we start, S is actually equal to 0 meters. Okay. When we stop, so we're traveling this way. When we stop here, then our arc length, the length of the rope around the drum, we actually don't know it yet. Okay, so we're looking to find here on the diagram is this piece right here. Right? That is like super, super, super ugly. I found that making curves on this thing are kind of difficult. There we go. Yeah. Okay. All right, so let's go ahead and get started. Let's check off what we have and what we're looking for. Do we have S? No. So that's the stuff we're looking for. Do we have R? Yes. R is given right here. Okay. And we can put equals, why not? And then theta, we also have given right here. Okay. So this is what we're looking for. Now, you have to know this about the arc length formula. Theta must be in radians when you plug it in. Okay, so the first thing we're going to do, get theta into radians. This is just one way to do it. You could actually do all of this in here in one step if you wanted to, but I would just recommend doing whatever's comfortable for you. So get theta into radians. We have theta equaling 132.6 degrees. And then remember the conversion factor. This is if you're going from degrees to radians. You're gonna have radians on top, degrees on bottom. Pi goes next to the radian part, 180 goes next to the degree part. Okay. So 132.6 divided by 180, that is 0.736 with a bar over it, radians. Here, don't round. You can just carry this over from your calculator into the next few steps. Okay, so, oh, and we need a pi there. Let me be there. Okay, so the 0.736 with a bar, that comes from the 132.6 divided by 180. Okay, so I'm just gonna leave it like that for a moment. All right, and then the next thing we're going to do is plug in R and theta to find S. Okay, so we know that S is equal to whatever R is times theta. So S equals 0.327 meters times 0.736 with a bar over it, pi. And radians, remember, are unitless. Okay, so then when we do our final calculation, S comes out to be 0.75677 and some change, which is about 0.757 meters. All right, that covers our first problem. So now on to the next recording.